Hello everyone, in this video we're going to be implementing binary search. However, we're going to implement it using recursion. So in this video we're going to implement our binary search algorithm and then test it. So let's get started. In Eclipse I've created a new project called binary search and we're going to add a new class called recursive binary search. Okay. So what we're going to have here is, well, our algorithm. So what we're going to have to start with is a static method. And this is going to return an int, recursive binary search. And what it is going to take is an int array, which represents our list, and int key, which is what we're actually searching for. So what we're going to have is we're going to initialize an int called low equal to 0 and an int called high equal to list.length minus 1. So we're setting the low and high values for the search, and then we're going to return recursive binary search int array list int key int low int high. Now this won't make any sense yet because we haven't actually implemented this method, but the idea here is that this method here is the entry point into our search. So it just takes a list and a key. What it does inside is initialize the low and high values to be the maximum and minimum values that are possible for our array. And then we call this other version of recursive binary search, which takes in these low and high values. What this does is give bounds for the search. Now I'll explain how this is going to work. So what color is my pen? It's black. Okay. So suppose this is our array, and it has values 1, 3, 4, 7, 11, 13. I should point out right now, binary search only works if the data is sorted. So we call search with our key and our array, but that's okay. So what this is going to do is set up the low value to be at 0 and the high value to be here. So this is H, this is low. And then what we're going to do is, the first thing, so let's not worry about the base case just yet. Basically what we're going to do is pick somewhere in the middle. So I've actually created a 6-element array. So let's pick this one. Now, if this is what we're looking for, then we return, no problems. If not, we call search again. So say we're searching for 3. What we do is, if the item we're searching for is less than the item we found, then we move the high value to be here. If it's the other way around, then we move the low value to be here. And then we call search again. So this is how the recursion works. We call search again with this subpart of the array. And then again we do the check. And then we have, but what will eventually happen is, if the item is not in the array at all, we'll end up with this kind of thing happening. High will be, high and low positions will be switched. If that's the case, it means we've searched the entire array and we can just return because we didn't find it. So that's how the recursion in this algorithm is going to work. So let's start off with our new method. So public static int recursive binary search int array list int key int low int high. And I just realized, I bet you guys realize this all straight away, is I accidentally typed the method signature into where we're calling the method. So I apologize about that. We're just going to get rid of all these declarations. Anyway, here we go. Down here now. The first thing we're going to do is our base case. Now remember, that was if high and low had been switched around because we've gotten to the end of the array. So if low is greater than high, that means that the item was not in the array, and we can return negative low, minus 1. This will make... So what we're saying is we're returning an index that is 1 less than the possible value we could have had. Which means it wasn't found. So what we're going to do now is just pick somewhere in the middle. And the way we're going to do of the part of the array that we're searching. So int mid equals low plus high divided by 2. So, and because these are ints, the decimal place will be truncated and we'll just end up with an integer value. So that's fantastic. We've picked the middle element out of the part that we're searching. Now, if the key is less than list at mid, that means that we need to move our high value, because the key we are looking for is less, sorry, the key we are looking for is less than what we found. So, and we're going to have a recursive call here to recursive binary search. So we're still searching the list. We're looking for the key. Low stays the same, but we're moving our high value to be mid minus 1. So remember, we have this situation. Low, high, mid. What we're doing is moving high to there in the next call. So mid minus 1. Now, what if it's the other way around? What if our key is greater than what we found? So, else if... Actually, what we'll do is actually check to see whether it is what we're looking for. So if the key was equal to list at mid, that's great. It means we found what we were looking for. And we can just return mid. So what we're returning is the index into the array where that element was found. Otherwise, that means it's greater than. We need to return recursive binary search. List stays the same. Key stays the same. Now what we're going to do in this case is move low to be 1 greater than whatever mid was. So mid plus 1 and high. And that's it. That's our binary search. So what we're going to do next is actually test this. So we'll create a new class and let's call this test binary search. Okay, so what I might do is actually copy and paste some test code just to speed things up a bit. So here it is. Now what this is actually doing is creating an array that has kind of a random collection of elements, but you can see here that the array is already sorted, which is really important for binary search. Then what we're doing is printing out wherever we found, so we're looking for 2, 11, 12, 1, and 3, and this is kind of a guide to what we expect it to return. So let's save that and run Java application. So there we go, printed out all the indices completely fine. So quickly to summarize, binary search efficiently searches a sorted array, but it doesn't work if the data is unsorted. Now, the recursive algorithm that we want, the recursive algorithm is one that calls itself. Now that means we have to have a base case to prevent infinite recursion. And in our case, it was making sure that low was less than or equal to high. So with that, that's it for this video. Thanks a lot.